Okay guys, so today we are going to start finding general solutions for inverse values. Now this is very similar to the principal inverse values, but like we talked about with those, there is actually more than just the one solution that we found for the principal value. So what we're going to do now is we're actually going to write an equation for basically all of the possible solutions that we could get to this question. So we're going to start this off just like we did before. We're going to find the sine inverse of root 3 over 2. So I'm going to start this off the same way I have, where I'm going to draw my triangle in quadrant 1. I'm going to fill in an opposite of root 3 and a hypotenuse of 2, and that makes my adjacent side 1, which means that theta is across from 30. So my theta, I'm going to do this all in radians. My theta is going to be pi over 3, which is 60 degrees. Now, in order to write a general solution, however, we need to realize that sine is actually positive in just more than just the first quadrant. Sine is also positive in the second quadrant. So to add to my solution, I'm going to draw a triangle in the second quadrant. Now what's nice is I already know what that reference angle is. That reference angle is going to be the same thing. It's still going to be 60 degrees, which is still it's still going to be pi over 3. But what I need to do this time is actually need to find what that whole angle is. So if I know it's a pi over 3 reference angle, then pi minus pi over 3 gives me that whole angle. So the sine of 2 pi over 3 and the sine of pi over 3 would give me a positive root 3 over 2. So my general solution is going to include both of those parts. It's going to be pi over 3, and it's also going to have 2 pi over 3. But there's even more that I need to add to that. Because it's not just those two angles, it's actually that same reference angle and every single coterminal angle to that reference angle. If I go around 1 time, 2 times, 3 times, it doesn't matter. All of those are going to give me that same value as long as it ends in that same place. Same thing if I go in the negative direction. If I go around 1 time or 2 times, as long as I end in that same place, it's going to be a solution. So what that means I need to write on my general solution is plus 2 pi n. Because that means I can add or subtract 2 pi as many times as I want to. N can be any number. It could be a positive number, a negative number, it's just any whole number. So I could add or subtract 2 pi as many times as I wanted to, and that would still give me an answer of that would still give me a root 3 over 2 as the sine of those angles. So the other thing we need to do is we need to find the first 3 positive solutions. So the general solution is all of them. The first 3 positive would be, there's my first one. Then if I go around again, I would hit the second one, and then the third one, I would go past quadrant 3 and 4, and then I would end back there. So those are my first 3. An easy way to think about the first 3 is I look at my general solution. The first value I would hit is pi over 3. Then the second one I would hit is 2 pi over 3. Then if I add 2 pi to either of those, the one that comes up first, the smaller of the two, is pi over 3. So if I add 2 pi to pi over 3, I would get the same solution. So I just need to get a common denominator and add those together, and I get my next positive value. So those are the first 3 positive answers to that possible equation. Alright, so what we're going to do from here on out, it's going to be very, very similar to what we did for principal values, but we're going to look at the other functions and we're going to look at some negative values. So we're going to start with inverse sine of negative 1/2. So we're going to do it the same way. Because it's sine and it's negative, I'm going to draw it in the appropriate quadrant. So I need to think about where sine is negative. The principal value was in quadrant 4. So I'm going to start with that one. I want my opposite and my hypotenuse to be 1 and 2, and then my adjacent side has to be root 3, which means that that angle, the reference angle, is 30 degrees or pi over 6. But I know one of those places is a negative pi over 6 in quadrant 4. So part of my general solution is negative pi over 6 plus 2 pi n. The other place where I could have sine being negative, if you guys remember, sine is positive in quadrants 1 and 2, which means it has to be negative in quadrants 3 and 4. So I already did quadrant 4, so now I'm going to draw a triangle in quadrant 3. That's the other place where that angle is negative. So I'm going to draw an angle over there. It's going to be the same reference angle. It's still pi over 6 in that in-between spot. So all I need to figure out is how much that whole angle is. So I'm going to do pi plus pi over 6. And I get 7 pi over 6. This is why it's really helpful to be familiar with that unit circle, because you'll see those angles continually coming back up. So my general solution here is 7 pi over 6. Now if you guys remember, what we talked about was that we need to find the first 3 positive values. So again, I'm going to look to my general solution to find that. If I look at the first value of my general solution, that's a negative pi over 6. That's obviously not a positive number. So the first positive value I'm actually going to have is 7 pi over 6. Then the next one I would hit would be negative pi over 6 plus 2 pi. So if I get a common denominator, then I would end up at 11 pi over 6. And then the next angle I would hit would be 7 pi over 6 plus 2 pi. So I need to get a common denominator again. So my third one would be 19 pi over 6. So that's my general solution and my first 3 positive x values. Alright, now we're going to work this up the same way, but we're going to do it for cosine inverse. Alright, so I'm going to draw a triangle all over again. Cosine is negative in quadrants 2 and quadrants 3. So I'm going to draw my first triangle in quadrant 2 because that's that primary principal quadrant. My adjacent is 1, my hypotenuse is 2, missing side is root 3. So that gives me a reference angle of 60 degrees or pi over 3. So I need to find how much that first angle is. So if it's pi over 3 in between, I'm going to do pi minus pi over 3, get a common denominator, and there's my first part of my general solution. Then I need to find the other quadrant where cosine is negative and draw that angle as well. And cosine is also negative in the third quadrant. So I know my reference angle is pi over 3. I know it's pi halfway around my circle, so I'm going to do pi plus pi over 3. And that's my second answer. So that's the second half of my general solution. And then I'm going to use my general solution to find the first 3 positive x values. So the first positive one from looking at my general solution is going to be 2 pi over 3. The second one would be 4 pi over 3. And then the last one would be 2 pi over 3 plus 2 pi. So I'm going to do 2 pi over 3 plus 6 pi over 3. And I'm going to get 8 pi over 3. And those are my first 3 positive values. Alright, so the last 2 we're going to look at are just 2 that have a little bit of trick to them. So I'm going to do tangent. I'm going to work it out the same way. A tangent needs to be negative. So if tangent is negative, the quadrants I could use are quadrant 2 or quadrant 3. So I'm going to start with quadrant 2 or quadrant 4. And I'm going to start with quadrant 4, because that's that principal quadrant. So negative root 3 means I have an opposite over adjacent of root 3 over 1. That means my missing side is 2. So across from that root 3, I'm going to have 60 degrees, which is pi over 3 in radians. So that is a negative pi over 3. Now I'm going to draw that same angle, that same reference angle in quadrant 2. So if I have pi over 3 as a reference angle, it's pi all the way around my circle. So pi minus pi over 3 gives me 2 pi over 3. So what I could do on this one, if you wanted to, you could write it as negative pi over 3 plus 2 pi n and 2 pi over 3 plus 2 pi n. But one thing that you might need to notice here that might make this a little bit shorter is that these two angles that I just found, my 2 pi over 3 and my negative pi over 3, they're exactly 180 degrees apart from each other. So a simpler way to write this, instead of writing both of those answers plus 2 pi n, is I can just take one of those answers plus pi n. Because if you think about that, if I take negative pi over 3 and I add 1 pi, and I get that common denominator, I get 2 pi over 3 is my next value. If I add pi again, I get 5 pi over 6, or 5 pi over 3, which is the same thing as negative pi over 3. So that's just a simpler way to write this. Again, if I want the first 3 positive x values, I would do what I just did. I just keep adding pi. So I got my first one, I did 2 pi over 3. The next one was 5 pi over 3. And then I add another 3 pi over 3, and I get 8 pi over 3. Alright, so my last one I want to do is actually not cosine inverse of 0. I copied the wrong question down. I want to do cosine inverse of negative 1. We're going to do that instead. That's the one I meant to have on there. So what I need to figure out is, first of all, when is cosine negative 1? So if I can't draw a triangle like that, that's an adjacent over hypotenuse of 1, and that doesn't work. So what I need to do is remember your little OIO chart. And I am looking for the place where cosine is going to be negative 1. And if you remember, the only place on there is at 180, which is pi radians. And that is the only place within the entire unit circle where cosine, between one full circle, that cosine will be negative 1. So the only answer I have here is pi. That's the only place. So to write my general solution, it's pi plus 2 pi n. There actually are not two answers for this one, so you don't necessarily have to have that. So if I want to find my first 3, it's going to be 1 pi, 1 pi plus 2 pi, and then I add another 2 pi. And those are my first 3 positive values. And that's all there is for general solutions. So it's very similar to those principal values, just basically one step farther. We're finding all of the possible places where I can get that answer.